Assalamu alaikum. This presentation is on a classic, useful, and simple way of exploring and organizing a small to medium size of a data set. Stem and leaf plots can be very useful not only in organizing the data, but also in displaying them in a graph-like manner and extracting very few information from this set of raw data, like what is the mode, where is the median, what is the range, and the cumulative limits at certain points. And it can be done manually. You don't need any softwares or any computers to do this. So long as the set of data is reasonably small, something around maybe 30 or 40 numbers, can be organized carefully, and then you can start extracting the information from this. The first step is to go through the set of raw data, count them. This is a set of 15 different data. The lowest, the minimum is this, 0.1, and the highest score is this, 3.2. So you form a stem. This is the stem part of the plot. And the stem is 0 point something, 1 point something, 2 point something, and 3 point something. The minimum is 0 point something. This is what we have here. And the maximum score was 3 point something. This is what we have here. So you form the stem of these 4 marks, 0 point up to 3 point. And then you go through the set of data one by one, starting from the very beginning. This is an 0.6. So you branch it from the stem at the 0 point something. Here you just write a 6. So this is the first leaf coming out from the stem, 0.6. Then the second one is 2.6. So you get the 2 point in the stem, and there you put the leaf here, 2.6, followed by 0.1 back to the stem, 0.1, and then 1.1. This is the 1 point in the stem, and then you put a leaf here at 1.1, and then so on. 0.4 is next. This is where you put the leaf with the stem at the 0 point, and then 2 point, the stem at 2 point, and then you put the 0, the 0.8 again, and so on. And in this way, you could organize all the set of the scores and as branches, leaves coming out from a certain stem. You've marked the stem, and you have now at this point 4 different leaves. At the next point you have 6, and then you have 3, and then you have 1. And this is another set of data representing the age of 30 different individuals. Again, you're just going to organize this because the minimum age is 18 and the maximum age is 78. So you put on the stem like each part of the stem represents 10 years. So this would be 10 years plus, 20 years plus, 30 years plus, up to 70 years plus. And go then through the set of data itself. You'll find a patient who is 18 years old, so the stem will be a 1.8. Remember, we're going to multiply this by 10 because this is what is the stem width. And there is another patient who is 19, so again he will come off the stem at the 1.9, and so on. There will be a patient who is 22 and another who is 29, and 5 patients who are 31, 33, 34, and 34, and 39, and so on. And now you have a histogram on its side, and you could tell where is the commonest age group, and you could tell also where is the commonest individual in here. and you can get the median and the range and the cumulative thresholds. Start by the mod. These are actual figures. You have here the actual ages for all the 30 patients. What is the commonest age here? You could see that the commonest age is here, 54, because here you have the stem at the 5 point and you have 3 patients who are 54, and this is the highest single age, so the mod is 54. Because the set of data here is 30, to find the midpoint it's somewhere between the number 15 and the number 16 rank. So you find out how many, where is the number 15 rank. You have 2 patients at 10, another 2 at 2, that's 4 patients so far, and then 5 at 30 plus, so that's 9, and then 4 at the 40 plus, that's 13, and then you count 2 from the 10 plus, from the 50 plus here, so that's 51. So 51 should be the number 15 score, and the number 16 score will be 54, because the median of an even set of number is the average of the 2 middle marks. So the median here would be the average of 54 and 51, which is 52.5. You get this manually very easily. The range is also clear. The minimum is 1.8, so that's 18 years is the minimum, and the maximum is 7.8, so that's the 78 years. Now, to cumulative thresholds, say if you want to know the number of patients below the age of 30, these are 4 patients here. If you want to know the number of patients above the age of 50, there will be 4 and 3 patients, that's 7 patients here. So you get all this very simple information on real numbers just by simple organization, and you get a nice histogram on its side. One more thing, if you have a set of data, say representing age of patients, and you could see that most of the data are in a certain range, like between 10 plus or 30 plus, most of the patients are below the age of 30 years, then you could actually get all the extreme numbers, all the patients older than 39, into one single STEM station in here. So you have a first station of all the teenagers, the 10s, up to 15 years old, and then from the 15 years old to the 19 years old, the 20 to 25, from 25 to 30 if there wasn't any patient, above 30 up to 35 there is only 1 patient, and then all the others, the 40s and the 50s and the 60 years old, could be put together into one station at the stem in here. That would make it easier than spreading the data along a very long stem. So that's a classic and simple and very useful way of organizing and displaying a smallish set of data manually without the use of any computers or software. Assalamu alaikum.